Right, so it's actually 3 o'clock. So I think we're going to start. People will probably drop in as we go. So welcome. This is the Swedish NLP seminar. My name is Magnus Ahlgren. I will be the moderator here today. And as most of you know, this is a seminar series that is co-organized by AI Sweden and the Natural Language Understanding Research Group that we have at AI Sweden, together with the Natural Language Processing Research Group at RISE. And this will actually be the last seminar for this year. We might meet up in 2 weeks' time, but only have like a Christmas fika at the office. So if you're in Stockholm, you can drop by, sign up for co-working and all that, and then we can have just a nice cup of glögg and maybe some gingerbread cookies and stuff like that. I think today we have a really interesting topic. I think this is one of the most interesting papers I have read in a long time. I think it shows some extremely interesting results and some really clever experimentation. And I'm really happy about things like this popping up now. And as most of you know, we're working with GPT models for Swedish and the Nordic languages. So this is extremely relevant and interesting from our perspective. And we're extremely happy to have Tanya, the main author of this paper, with us today. Tanya is actually at EMNLP in Dubai. So we're really happy that you could take the time out to join us here today. And so I will give you the floor to present this great paper. Go ahead, Tanya.
Thanks, Magnus. Like I was mentioning before, this is the first time I'm presenting this work, so I'm also very excited to hear everybody's thoughts on this. Okay, let me get started. So today I'll be talking about this work that we did on evaluating on basically seeing how new summarization happens in the era of GPT-3 and how do we evaluate this. This was joint work with Jesse and my advisor, Greg Durrett from UT Austin. So it seemed only right to start off this talk by first talking about ChatGPT, which is a large language model that was released by OpenAI in the past week or so. And this is a language model that was specifically optimized for dialogue. And over the last week, my Twitter at least has been filled with posts about people sharing their own prompts and their outputs. So I've included a few fun ones here. So here, the prompt is, write me a limerick about an alien with cold feet who discovers socks on Earth. And ChatGPT spits out this nice little poem, which is, there once was an alien with cold feet who landed on Earth so neat, and so on and so forth. And what's interesting about this is, first, it knows what limerick is, which is fine, but it also knows what rhyme scheme to follow, which is AABBA. So this was quite nice. Another example here is, I've eliminated the prompt, but the prompt was, give me a rap battle between Elon Musk and Jack Dorsey, and it spit out this rap battle, which again I thought was quite fun. Of course, at the time when ChatGPT was probably trained, it didn't know that Elon Musk would be the new owner of Twitter, so it's from that era. But across both of these, we see that the model is very good at generation, irrespective of whether we like the limerick or not, or we can quibble about a few facts and stuff, but the text quality is pretty high. So the question that we need to ask as researchers or NLP practitioners is, how do we benchmark these models? How do we methodologically evaluate how good these models are? And if we step back a little, people have been playing around with prompting and large language models for a couple of years now, starting from the first GPT-3 model or the paper that was released in 2020. And the way we've been evaluating how good these models are is by testing them on specific NLP tasks that we want to solve. So for instance, if our task was natural language inference, which is basically given a premise, for instance, an older man is drinking orange juice at a restaurant, and a hypothesis, a man in a restaurant is waiting for his meal to arrive. We want to be able to predict whether this hypothesis is entailed by the premise or not, right? And the way this kind of a problem statement is converted into the prompting setup is we just create a natural language prompt, which is premise, and using this description and word knowledge, is this hypothesis entailed or not? Yes or no? And when we give this prompt to GPT-3, this is the answer that it spit out. It said, no, it is definitely not correct, which is true. But it also included this nice explanation, which is, it does not give us the information to determine if he's waiting for the meal to arrive or not. So again, we see that for classification tasks, which is where the label space is finite, we can use GPT-3, or we can benchmark GPT-3 using our normal metrics like accuracy, F1, whatever. But how do we evaluate how well they do at generation? Like, how do we evaluate whether that limerick was nice or whether that rap battle was nice or not? So the way we decided to do this was to look at text summarization, which is a popular test bed for generation capabilities. People have been working, firstly, summarization is an important task. It's a useful task. And people have been working on this research direction for I was going to say a couple of years, but I meant couple of decades now. So the question now is, how well does GPT-3 do here? So I want to start off with an example. So here's an input article which says paramedics in the Lake District hope to be using jet. One second. Yeah, so it says paramedics in the Lake District hope to be using jet suits to reach medical emergencies this summer. And it talks about a staff member who's completed his training. To get a summary out of GPT-3, we give it this article and then a prompt which says, summarize the above article briefly in one sentence. And this is the summary that GPT-3 gave us. It said, it's a good summary. It basically says the article describes how this ambulance is hoping to use jet suits for medical emergencies, which would be a world first. Now, this is how GPT-3 does. If we compare it to prior summarization models, these are what those summaries look like. So for instance, if you look at the summary, it just says the world's first jet suit paramedics are set to take to the skies in a bid to save lives. So again, this is a correct summary also, but it is very different, or rather the style is very different from the GPT-3 summary. So just by looking at these two, we don't know what a broad set of humans would prefer, right? If you look at the second summary though, here, this is another state-of-the-art summarization model from prior work. And here it said something like, a pilot has completed his training to use a jet suit to reach patients in Scotland. And this part, Scotland, is a factual error. It should have instead generated some Lake District or something else. Okay, so the 2 points I wanted to make here with these examples are, first, the style of GPT summaries are very different from the prior fine-tuned summarization models. And we need to basically compare against these models. Second, GPT-3 summaries also sometimes make errors, but they don't really make the same kind of factual errors as these previous summarization models. So how do we evaluate these summaries? Okay. So again, with this paper, even though we were seeing all these good results when we were playing around with the GPT-3 playground, we wanted to go beyond this anecdotal evidence and methodologically compare prompting models, which is GPT-3, and fine-tuned models. And if we look at the current evaluation landscape, there are two ways to do this comparison. First is human evaluation, which is we ask human annotators to rate GPT-3 summaries, either in isolation or in comparison with these other models. And this is going to be our gold standard. The other option here is automatic evaluation, where, again, this is divided into two parts. One, we compare the generated summary against a reference summary that we have. or we use a trained metric that does not use a reference summary, but instead uses a function of the input article and the generated summary to evaluate the generation. And in this paper, I will cover all these aspects. I'll first talk about what human evaluation tells us and how our automatic metrics do at this task. Okay, so this is going to be the broad talk overview. First, I'm going to spend some time talking about why GPT-3 is such a big paradigm shift and why we need to care about this. Then I will talk about human evaluation, about the study that we run to compare GPT-3 and fine-tune models and the results that we got. In the next part of the talk, I'll talk a bit about automatic evaluation and basically try to see if the current suite of metrics that we have are able to evaluate GPT-3 summaries or not. And finally, I'll talk about some other work that looks beyond this generic summarization task where you just give it an article and ask it to summarize, but looks at very specific things like, can it summarize an article based on a keyword or an aspect, or can it summarize very long documents? So just to give a bit of context, the results from the second, third, and fourth part of the talk is something that we put up on archive a month or two back, which is this paper, New Summarization and Evaluation in the Era of GPT-3. And I'm also going to talk a bit about long document summarization evaluation, which is a part of this other snack paper that is now going to be presented at EMNLP later this week. Okay, first let's look at why this is a big paradigm shift. Okay, so I've sort of made this timeline from 1950s to like today. And I'll talk about first the summarization systems that we've had. So in the very beginning, we had extractive summarization systems where given an input document, we are just choosing, or systems were trained to choose particular sentences or segments to include in the summary based on how salient they were. Then there was a lot of research which combined these extractive summaries with compression. So for instance, given a sentence, you could possibly choose to remove things like prepositional phrases or other things that were deemed to not be salient. But a lot of this changed 2016 onwards when we discovered end-to-end neural models, or when we got end-to-end neural models to work. And since then, we've seen pre-trained LMs come into play, and now we have these prompting-based models like GPT-3. Parallel to this, if we talk about datasets, before, the usual trend was to manually curate test sets for use case oriented tasks. So instead of saying, or in addition to saying, give me a summary, a generic summary, there were also specialized tasks like update summarization, which was introduced in TAC 2008, or guided summarization, which was introduced in TAC 2011. But since 2016 onwards, when we started to train end-to-end neural models, we also needed a lot of data to train these models. And since then, we've mostly been training and testing our models on these automatically collected large-scale data sets that we automatically scrape from the internet. So I'm going to talk about both these things in a little more detail now. But basically focusing on this part, which is 2016 to now. Okay, so first let's talk about fine-tuned summarization models. So the base that we have here is a pre-trained language model. So let's assume something like BART or Pegasus. And this base model is fine-tuned on a large-scale data set, such as a CNN Daily Mirror data set or Excel. Like I said, these data sets are collected by automatically scraping the internet. So you, for instance, you get articles and you get any summary adjacent text that you could find associated with these articles. And this kind of a strategy allowed us to create these large data sets very easily. But let's dig a little deeper into what these data sets actually contain. So again, it's the same summary, it's the same article from before. If this was the CNN Daily Mail article, the way the summaries were obtained is that back in the day, CNN and Daily Mail used to have the story highlights part associated with each articles, which was just the set of bullet points that were written by humans. And these were considered to be the gold summary, and models were trained to kind of emulate these. But the question that we need to ask is this the best way to present information? Yes, it was easily accessible, but one thing that we can see is that it doesn't really flow here, right? So it talks about the GNA staff first, but then it talks about the fact that it's going to be used to, like, it doesn't explain what GNA is, firstly. So there's some amount of like coherence issues in this story highlights. And the reason why this is critical is that when we train models on this data set, their performance are going to be upper bounded by how good these references are. Let's quickly look at how XM was created. And the reason why I'm focusing on these two data sets is because a lot of the new summarization literature in the last 5-6 years has concentrated majorly on these two data sets. And it's, yeah, so which is why it's important to dig into these. So if we look into XM, the way this was constructed was the first sentence of the article was removed, and that was considered as the gold summary, whereas the rest of the article was now considered the input article. And the problem with this data set now is that the gold summaries themselves are very noisy now, because for instance, here, the part about Lake District is not included anywhere in the rest of the article. So when we train a model on this kind of data set, it just learns to hallucinate all these facts because that's the training data. And we saw an example of it in the generated summary before, where it hallucinated Scotland. Okay, so I spent around 5 minutes talking about why these data sets are bad. But I also want to say that these data sets have been very useful because they've spearheaded a lot of progress in the last 5 years. So for instance, consider this input article, which is talking about this American, Jennifer Stewart, who was devastated because her cat was lost on a flight from UAE to Chicago. And if we look at the first baseline, or not the first, but the baseline seek-to-seek model from 2016, we saw that it used to generate summaries like this, which were pretty poor quality. So for instance, here, it says American Jennifer Stewart says that she's devastated to learn that Ankh has lost her baggage was lost, and her more important baggage. So it's kind of a mess, right? But by having these data sets to play around with and improve models on, the pointer generator model, which was introduced in 2017, was able to generate much more fluent summaries. But again, this was also not perfect because it preferred to copy long spans, but sometimes it wouldn't put these spans together in the right way. So for instance, here it says that she was devastated to learn that she booked Felix on the Etihad flight, which is not true. But by continuing to work on these data sets, we now have BART and Pegasus kind of models, which generate much more coherent summaries. So for instance, here in the last example that I have, it follows a nice structure where it first talks about what happened, which is that the cat was lost, why it happened, and finally, what is the follow-up, which is that the airline is investigating. So what these examples show us that we've made a lot of progress in the last 5 years by working on these data sets. But now we are in the era of zero-shot prompting, where instead of trying to train models to emulate these kind of cold summaries, we just give the model the article and we ask it to summarize the article. And because of this, generated summaries no longer follow the quote unquote style of the reference summaries. And in order to demonstrate why this is a big shift, let's look at this sub-problem of automatic evaluation. Before I talked about two ways automatic evaluation is conducted. First is comparing the generated summary with the reference summary. But now, because generated summaries no longer need to follow the style of reference summaries, will this evaluation paradigm even work? If we look at the second one, we used a trained metric to evaluate the generated summary. But now again, we trained it on one sort of generations, but now there's been a distribution shift. So we don't know if these will work after the distribution shift. And these are the big problems that we need to look at. Okay, so next I'm going to talk about human evaluation, which is how do GPT-3 based summaries compare to these fine-tuned models. Okay, so first, which models do we want to compare amongst these two different paradigms? Before I want to talk about that, I want to just say that these two are at the extremes, but there is this third kind of models, which is instruction tuned on multiple tasks, which sort of lie between these two. What this actually does is that it further trains a large language model on training data that has demonstrations from a wide variety of tasks. So for instance, here I've shown a translation example. Give it the input, translate the sentence to Spanish and give it the correct target. And you fine tune on this and other tasks to basically teach the model how to respond to instructions. And one of the reasons I said that this is between fine-tuned on summarization datasets and zero-shot prompting is because this training data can include summarization datasets. We don't have a lot of clarity in the data that OpenAI uses, but it's possible that the instruction-tuned models that we look at actually have CNN Daily Mail or XM training data. And finally, just like zero or few-shot prompting, once we have this model, we can prompt it with instructions to generate the summary. Okay, so I have listed a couple of, or not a couple, a lot of model options that we had within each of these categories. And this is in no way an exhaustive list. So the models that we chose to compare was from the fine-tuned summarization datasets. We chose the Brio model, which is the best performing fine-tuned model that we have right now. Between instruction-tuned and zero-shot, we chose to run our experiments on the text DaVinci 002 model, which is an instruct GPT model. And it's been shown to perform much better than the earlier versions of the GPT-3 models. So we wanted to basically benchmark the best available GPT-3 model available at that time. And between these two, we also wanted to test another instruction-tuned model, which is T0, which has a similar instruction tuning training setup, but it's at a much smaller scale. It's basically a T5 scale model. So these were the three data sets that we compared. The three models that we compared. Now, let's move on to the task design. The basic task that we gave to human annotators was this. We showed them the input article, which is on the left, and we showed them summaries by these three models. And we chose the order of these summaries randomly for each annotator. And we asked them two questions. Basically, first, which summary do you prefer the most? And they were allowed to choose multiple summaries, and also asked them to provide a free text explanation of why they chose that summary. Next, we asked them which summary do you prefer the least? And again, they were allowed to select multiple summaries, and they had to provide a explanation of why they did that. Okay, so let's now talk about the data set that this was evaluated over. So we conducted this evaluation over two styles of summarization data sets. I've mentioned these before, CNN and XM. And the reason we chose this is because the reference summaries or these data sets are very different from each other. And between them, they cover a diverse set of summarization phenomena. So for instance, CNN summaries are 3 to 4 sentences, XM summaries just 1 sentence. CNN summaries or models that are trained on CNN datasets tend to generate summaries with long copied phrases, whereas XM summaries have negligible copy. So basically very different. And to generate GPT-3 summaries that kind of emulate these styles, we only focused on the length aspect. So the prompt that we gave GPT-3 was either summarize the above article in 3 sentences for CNN or summarize the above article in 1 sentence for XM. A little more detail about the data set we evaluated over. So we scraped around 100 articles from each of these 2 sources from March to June 2022. And this was done to avoid overlap with GPT-3's training data. So if we had used the existing CNN or XM benchmarks, because these were collected around 2016, 2017, we were pretty sure that GPT-3 must have seen those articles in its training. In addition to that, we asked 3 annotators to judge each article's summaries, and we used the Prolific platform to recruit these crowd workers. Okay, let's look at the results now. So the metric that we evaluate is, or we report, is the percentage times a particular model was selected as the best or the worst according to the majority vote between the 3 annotators. And this is what the results look like. So first, we see that GPT-3 was voted as the best model more than the other 2, 58% of the times for CNN and 57% for BBC. So it very convincingly beats these fine-tuned models from prior work. But if we look at the BBC specific results, we see that the Brio model, which was a fine-tuned model, fine-tuned only on the XM dataset, was voted as the worst model. And this we expected because it's fine-tuned on this very noisy dataset with factual errors. We saw that it generated a lot of factually incorrect summaries, which annotators penalized. The interesting thing here is that T0's training dataset also contained XM, but because it had this whole instruction tuning framework where it was also trained on a lot of other tasks, that kind of helped offset the noisy training from XM. So this basically shows us some of the nice side effects of instruction tuning. One thing I want to quickly add is that in the last, I think maybe 3 weeks back, there's this paper, Helm, which was released by the folks from Stanford. It's holistic evaluation of language models. And they did this big analysis with a lot of tasks and a lot of metrics. But the summarization specific result I want to highlight here is that in addition to the results that we had, they showed that zero-shot GPT-3 models, or and I mean the instruction-tuned versions here, they were even more preferred than the human written references in both CNN, Daily Mail, and XM. And what this kind of a result basically shows us is that it reiterates the point that even though we constructed these data sets and we've been using them as gold summaries, those were not meant to be summaries by the humans who wrote them. So this calls into question the utility of continuing to hill climb on these data sets that we now convincingly know are not perfect. Okay, let's get back to our results. So even though we saw that GPT-3 outperformed both the fine-tuned models by a large margin, the one question that we have is, because this task is inherently subjective, like when we were looking at those two summaries, different people could have different preferences for what they thought was the better summary. So we wanted to see how often do human annotators agree with each other. So first, let's look at this agreement for the question of which summary is most preferred. And what's shown on this graph here is the number of annotator votes that each of the systems got for best summary. And here, this shows a very interesting picture. So it shows that even though for more than 58% of the cases, GPT-3 was the majority vote, this was only unanimous less than 30% of the time. So, so what is basically saying is that for more than 60% of the cases, at least one of the annotators thought that Brio was the better summary, which highlights the inherent ambiguity in conducting this kind of human evaluation. And I won't go into a lot of details here, but we found similar results when we asked which summary is the least preferred. Which again, just to reiterate this point, this task of evaluating the quality of generated text is subjective. Okay, so let's look at a few examples of generated summaries now. And because Brio summaries had a lot of factual errors, I've ignored all of these and all of those and included an example here where it did not have a factual error. So it's again the same article from before, and we saw the GPT-3 summary before, and we also saw the Brio summary before. And according to human annotators, according to 3 human annotators, 2 of them voted GPT-3 as the best summary, and 2 of them voted Brio as the best summary. And the exact reasons that were given were the Brio summary here did not have enough details about what's happening. It was just very vague. And for the GPT-3 summaries, annotators felt that it contained all the salient information that they would want to see in a one-sentence summary. Okay, let's look at another example, which is from the CNN dataset this time. I'm going to quickly go over the example. It's just, or the article was just talking about what it means in political terms for COVID to be declared over. And it talked about a bunch of things. It talked about Hawaii's mandate, or Hawaii ending its mask mandate, to California governor's comments, and so on and so forth. And GPT-3 generated quite a nice summary here, which was basically, it followed the flavor of the article, which is give an overview of what's happening. The article discusses the debate around the COVID-19 pandemic. It argues that in political terms, the pandemic will be considered over when all states have lifted their indoor mask mandates, blah, 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 right? On the other hand, when we look at Brio summaries, this is what it generated. It just spit out a lot of facts that it selected from all over the article, which is Hawaii will become the last state to end its mask mandate. The COVID-19 pandemic has seen a surge of cases. Many states have announced they will end their mask mandates. This part is actually over because Hawaii is the last state, but it's hard to imagine a return to normalcy and things like that. And the annotators kind of reflected that in their annotations, which is all of them selected GPT-3 to be the best summary, and 3 annotators thought Brio was the worst. And this was the reason for selecting GPT-3 as the best summary. It's the most fair in explaining the biggest points of the article, whereas for Brio, it said it did not reflect the tone of the article at all. Okay, so this concludes the human evaluation part. So in the last part, we talked about the human preference for summaries, which summaries did humans prefer. But to be able to make progress on this kind of a direction, human annotation is tough and time consuming to conduct, right? So we need automatic metrics that we can use to basically evaluate whether we are making progress or not. So next, we evaluated how GPT-3 summaries can be evaluated using the menu of automatic metrics that we have currently. Okay, so like I said, these are divided into two parts, reference-based metrics and reference-free metrics. And just to give a little bit of experimental setup, this time, because we did need reference summaries for the first part, we went back to our benchmark datasets of CNN and XM, and we randomly, CNN, XM, and two other datasets, and we randomly sampled 500 summaries from these datasets and conducted an evaluation on that. Okay, first, let's talk about reference-based metrics, which compares the generated summary against a reference summary. So I made up two summaries here just for illustration purposes. The first group of metrics that we'll evaluate are the most popular ones that people use, which is the lexical overlap based ones, where the word overlap between this generated and reference summaries is computed. So this includes things like rouge, blue, meteor, etc. The second category is distribution similarity based metrics, where an encoder model is used to get vector representations of both the generated and the reference summaries, and a similarity between these two is computed. And this last category of models is the QA-based models, where you basically use automatic QA/QG models to ask questions of both the generated and reference summaries, and then compare whether the answers match or not. So let's look at some results. So I've listed the three categories of metrics that we have and the specific metrics that we use within each of this. And we compare four models here, the three models that we had from before, and also we've added the Pegasus model, which was state of the art on the other two data sets that we looked at. And what we want from this, to be able to say that an automatic metric is good, we want it to be able to rank the systems in this order, right? GPT-3 greater than Brio greater than T0 for CNN, and GPT-3 greater than T0 greater than Brio for XM. And within this, we kind of want Pegasus to be similar to Brio because their quality is pretty, they generate the same kind of summaries. And these are the results. And I know I've thrown a lot of numbers here, but the high level takeaway that we can get from just looking at these colors is that consistently GPT-3 was rated as the worst summary for both those systems, even though our humans annotators preferred these summaries much more than other systems. If we zoom in on the rouge numbers, for instance, we see that it's not just that it's rated as the worst summary, but it's rated as the worst summary by more than 7 rouge points. And just to put this in context, a lot of papers in the last few years have been published by reporting 0.5 improvement on rouge. And now here we have a GPT-3 model that humans prefer overwhelmingly, but is 7 rouge points lower than all these competing models. So this kind of results basically show us that none of these metrics can be used to evaluate GPT-3 summaries. So maybe reference-free metrics would be better. Let's look at how these do. So again, just to talk about the categories of reference-free metrics that we have, there are two categories broadly. One are which evaluate the overall quality, and I won't really go into a lot of detail about this, but the second group of metrics is ones that evaluate the factuality of the generated summary. And this factuality based, the reason I mentioned factuality especially is there has been a lot of efforts that have been put into this area of research in the last 2-3 years in summarization. So let's just look at the factuality specific metrics that we have. Again, one major category of metrics here are QA-based factuality metrics, which take the input article and the generated summary, ask questions of both these using a QA model, And then they rate the summaries as factual if both the input and the summary give the same answers. Otherwise, it's non-factual. And I've only listed 3 papers here, but there are at least, I don't know, at least 10 papers that have tried to make progress along this line of work. The second category of models that we have here within factuality are trained metrics that basically learn a function of the input and the generated summary, and it predicts whether it's factual or not. And this function is parameterized by a pre-trained encoder model. And a lot of my own work has been along this line. Okay, let's look at some of the results here. Again, what we want remains the same, and what we get is now this. Again, without really looking at the numbers, what we can see is that there is no metric that correctly ranks the systems across both these data sets. So for instance, if you look at the overall quality, it seems like the ranking of GPT-3 being better than the other systems is correct for XM, but it's incorrect for CNN. And similarly, for the factuality-based one, even though it seems like the factuality-based metrics are doing the right thing for GPT-3, for XM, they're not doing it for CNN. So basically, if we look at both these data sets together, there is no metric that we can really trust. So this basically, so given these results, we tried to reason about why automatic evaluation fails. And for reference-based metrics, I think this is easier to understand. We've already spoken a bit about this. We know that we were comparing against reference summaries, and because GPT-3 does not try to emulate these reference summaries, these metrics kind of fail. And looking at our results, and by even reasoning about it, we can kind of predict that this will also not work for future zero-shot LMs, because again, they will also not follow the style of reference summaries. But the more interesting question is, why did the reference-free summaries, or why did the reference-free metrics fail this badly? So let's look at the two kinds of metrics separately. If you look at the trained metric, it was trained to predict, it did not use the reference summary, right? It was trained to predict the factuality given just the input article and the generated summary. But the training data that it was used to train did include reference summaries. So for instance, to train this model, we used reference summaries as the positive examples. And so even though it was reference-free at evaluation time, it was trained to reward the reference summary behaviors that it had seen in these data sets. If you look at QA-based factuality, on the other hand, the reason we hypothesize that this fails is because a lot of the metric components that were decided, which is which QA model to use, which QG model to use, how do you do the matching between the two answers, all of these design decisions were made and evaluated on fine-tuned models. And this did not transfer to GPT-3 summaries. So our overall feeling here, or at least my overall feeling here, is that the reference-free summarization setup is more promising, and this is the setup that can potentially be improved by aligning with the test conditions in future work. Okay, so with that, I'm going to move on to this last part, which talks about going beyond generic summarization. And I'm going to talk about two settings here. First is the keyword or aspect-based summarization setting. And the second one is the long document summarization setting. Okay, first, what is aspect-based summarization? So like consider this input article, and I promise this is the last article that I'm going to introduce. It says that Republican defenders of Donald Trump won't or can't answer the questions that are at the read. It's basically related to this recent controversy about him having classified documents at Mar-a-Lago. And an aspect-based summarization task was was formalized in TAC 2011, which was that given this article, it would first categorize it as under investigations and trials. It had 5 categories, and it had predefined relevant aspects for each of these categories. So for instance, for this article, a relevant category or a relevant aspect is what is the defendant's reaction to charges, including admission of guilt, denial of charges, or explanations. And the idea here is that this aspect would be relevant for all articles that fall within this investigations and trials category. So given this aspect, I've converted this to a GPT-3 prompt, and this was the summary that GPT-3 spit out. The defendant's reaction to charges in the above article is a denial of charges, which is correct. And then it gives some more explanation about that. So what we found here is that GPT-3 model was able to parse these abstract concepts such as defendant related to Donald Trump and answer the questions based on that. So this was quite promising. And I don't have examples of this on the slide, and you can check it out in the paper, but the prior model that we tried not prompting, but we tried for this same task did not basically work. Okay, let's look at another example of aspect-based summarization, which is here the aspect is who is a defendant or under investigation. And for this, we see that GPT-3 basically totally degenerates, and it spits out all entities that it sees in the input. So this good performance that we were seeing with aspect-based summarization wasn't really reliable across a series of examples. And one thing I want to add is that we also saw this thing of GPT-3 hallucinating facts when we asked it a question which was unanswerable. So for instance, here, if I'd asked what was Donald Trump's daughter's reaction, even though that's not in the article, it wouldn't abstain, it would still generate something. Related to this aspects-based summarization task, we can see that constructing a training data set for this to train fine-tuned models would be challenging, and it would likely require some human annotation. So instead of that, what emerged as a popular guided summarization setting was keyword summarization. And that would include something like extracting a keyword and asking the model to generate a summary that focused on that keyword. So here's the relevant GPT-3 prompt that we tried out for the entity William Barr. And again, under this setting, we saw that GPT-3 does pretty well in the sense that it first, William Barr was a minor entity in the context of this article. So it spent some time trying to contextualize this article, which is the article discusses how various Republicans have been defending Donald Trump. Some have downplayed significance, some have outrightly denied it, but former attorney William Barr has done this. So this was quite a nice positive example. We also ran a human evaluation to actually basically benchmark how good GPT-3 was compared to prior fine-tuned models for keyword-based summarization. And these were the results that we got. Again, according to majority vote, we saw that around 70% of the times, human annotators preferred GPT-3 summaries compared to control sum. And I've also included this this graph of annotator agreement, but both these basically show that overwhelmingly GPT-3 summaries were preferred to control sum, much more than the generic summarization case. Okay, so in this last part, I'm going to talk about long document summarization. And the reason why long document summarization is interesting is because most of the actual summarization use cases that we would be interested in would be cases where reading an entire document is time consuming, but these don't nicely fit into the setup that we currently have because of long contexts, right? So we tried zero-shot summarization by segmenting a long input article and summarizing each part separately. And this is the kind of summaries that we got. I've removed the summaries from the latter segments, but if you compare the summaries of these two, you would see that because GPT-3 could infer a lot of context, it generated the same things and it had a lot of repetition. And this basically shows that there are a lot of coherence issues in doing this simplest thing with zero-shot GPT-3 models. And to be able to make this work for long document summarization, we would need to do something more. So even though we were very interested in this long document summarization setting, we don't really have good test beds for it within news. But what people have been working a lot on in recent times is narrative summarization, which is a popular test bed in the summarization literature for long document summarization. So this is what this narrative summarization tasks looks like. Say, given an outrageously long input like a whole book, you have to summarize this in around 200 to 500 words. And the reason why this is much more interesting than, let's say, long news summarization is first, it's a pretty challenging task that can't really be solved by extraction alone. Models will have to learn abstractive strategies. And the second thing is that in general, these are very complex narratives that involve stories of different characters and how these intersect. And any summarization model would have to learn how to deal with all of that. So just to give you a sense of where the current state of affairs for this kind of task is, the current SOTA is again a GPT-3 model that was released by OpenAI, but this is a model that was specifically fine-tuned on book summarization. And it had this training setup where there were humans in the loop who would write summary demonstrations for a particular input or rank generated summaries during training. So, and the way they would deal with this big input was segment it, summarize it, and do this recursively till you get a summary of the size that you want. And here's an example summary. So first, just by looking at this, this is quite an impressive summary. So for instance, if you just look at the first two sentences, Miss Manet receives a letter from the bank informing her about her father's small property, and Mr. Laurie explains that her father's been found. These two sentences are summarizing a couple of pages of dialogue. So there's also like an element of style transfer here, and the summaries are largely grammatical. Also, another impressive thing, which isn't really obvious from just looking at these 4 sentences from the beginning of the summary, is that mostly these summaries, even after this recursive summarization setup, manage to retain the most important parts of the book. But what we see here is that it also has these coherence errors, not of the same type that we saw with zero-shot summarization, but still pretty prominent. So for instance, in the first 2 sentences itself, it's introduced these 2 characters, but given no background about who these characters are, right? Second, there are a lot of like sudden jumps in the summary. So the first 2 sentences were talking about a conversation between 2 characters, does not resolve that scene, but suddenly starts talking about a 3rd character who's been accused of treason. And just pointed out another coherence error here, where it says that somebody was acquitted after his friend testifies against him. And this kind of a error can actually be resolved by using better connectives, like despite his friend testifying against him, he was acquitted, but in its current form, it's inconsistent. So So again, the need of the hour here is better evaluation metrics to be able to actually say that these summaries are bad. And we took the first step towards that in this work called SNAC, which will be presented at NLP later this week. And the basic approach we followed was we defined firstly a high-level taxonomy of coherence errors that was grounded in actual errors made by these summarization models. So I've already defined 3 of those types of errors before. And a last error that we add here is missing reference to object or event, which corresponds to cases where it introduces a new object, but pragmatically, it seems like there must be more information about that object. In addition to these coherence errors, we also introduced some language errors just for the purpose of annotation. And I'm not going to go over a lot of this, but let's just look at the distribution of errors that we got after we ran this human annotation. In general, broadly, we see that these state-of-the-art summarization models make more coherence errors compared to language errors. But within coherence errors, character errors and event errors were the most common. An interesting product of this work was that we found that we could train models to detect errors. So for instance, here the setting is given context. We want to predict whether the next sentence is coherent or not. And again, to step back a little, the reason why we want automatic models to be able to predict coherence errors is so that we can have a metric that can automatically compare models. Right? So in this example, given S1, the model should predict that S2 is coherent, and given S1 and S2, it should predict that it's not coherent, plus also kind of generate what's not coherent. And to quickly go over the results, the metric that we computed here was sentence level recall at some precision level of 0.7. And we found that we got reasonably high recall for most of these error categories. And the interesting thing here is that we were able to use a weaker T5 model to critique a stronger GPT-3 model, which gives us a way forward to be able to evaluate these kind of models. Okay, so I know I'm kind of over time, but I'm going to end this talk with some 3 high-level takeaways. The first is the first point I want to make is that maybe it's time now to retire CNN Daily Mail and XM and move beyond this new summarization setup. First reason for that is, in any case, short news articles may not be the actual use case that we are targeting. Incremental ROOJ improvements, which has driven so much of the research in the past few years, is not useful. And we've seen this in a lot of ways, but we also saw that so much of the factuality research that focused on these data sets did not transfer to this GPT-3 setting. Okay. The second point that I want to make here is that because we no longer require large data sets to fine-tune summarization models, it gives us this opportunity now to actually align our summarization goals in research to actual end user needs. And one way in which prior work has thought about it is in this brilliant paper by Karen Spark-Jones, which encourages people to think about these 3 factors: input factors, what kind of inputs do people want summarized, long articles, short articles, text, videos, etc. Purpose factors, what is the purpose of the summarization? Is it revision? Should the summary be informative, etc. And output factors, what kind of summaries should be generated? And back in 2017, when we started focusing on new summarization, our models didn't work well enough for us to consider users. We were just trying to make sure that the models generate fluent stuff and grammatical stuff, but now our models work well. So we can now really start focusing on end user needs. In the interest of time, I'm going to skip this slide, but the TLDR here is that paper recently did this kind of a survey for input factors and saw that only a small percentage of users actually wanted short articles summarized like CNN Daily Mail, but would more rather have longer articles and multiple documents summarized. And finally, the last thing that I want to say here is that evaluation remains a concern. Prompt-based models do not follow any template, so they can behave in unpredictable ways. And how do we build error detection systems if we cannot predict what those errors would look like? I've listed two kind of ideas that I have, or like that can possibly used to address this problem. And I can talk about this more during the discussion section if people are interested. Okay, so finally, I'm going to end with these three main points. First, GPT-3 is a small summarization model. We show that it outperforms fine-tuned models on incidental data on the news domains. But what we also show is that better evaluation is required if you want to continue experimenting with GPT-3 based summarization. And data sets like SNAC and other human annotation efforts like Scarecrow, for instance, help characterize the errors made by these SOTA models that future work can build on. Thank you so much for your time. And I want to also add that all the data that I spoke about, generated summaries and human annotations, is available at this link. And I can take questions now.